The chemical compounds are formed by atoms get together, forming chemical bond between them, which you will learn in this chapter, chapter 12, chemical bondings. Let's recall what you learned about the atomic structure of an atom. An atom contains a nucleus where proton and neutron reside and electron orbit around the nucleus. The atom has core and valence electron. The core electron is found closer to the nucleus than like these two electrons, where the valence electrons are found in the more distance and usually in the S and P energy subshell. It's advanced electrons that are responsible for holding two or more atoms together in a chemical bond. Here's a symbol of an oxygen molecule. The valence electron in the oxygen atom are responsible for holding the two oxygen atoms together to form oxygen molecules. Before talking about chemical bonding, let's talk about octet rule. The octet rule states that atoms bond in such a way that each atom acquires 8 electrons in its outer shell. There are two ways in which an atom may achieve an octet. An atom can have its electron transfer from one to the other. For example, here in this example, the electron is transferred from N plus anion to N minus anion. Electron can only share between the atom, and then it can be one or more pairs of electron share. Here's a symbol of two N atoms. The electrons are shared between them, forming an N2 molecule. So go back to look at the electron dot configuration of an atom that you learned in the previous chapter. When you write electron dot configuration in an atom, you use the valence electrons and put it around that atom. For example, potassium has 1 valence electron, you put 1 dot. Magnesium has 2 valence electrons, you put 2 dots. Carbon has 4, you put 4 dots. Chlorine has 7 valence electrons, so you put 7 dots. To complete the octet, they must wrap a valence electron from another atom, so the total electron would be 8. For potassium, it only has 1 valence electron. It needs to wrap 7 more from other atoms. The green dots here represent the 7 valence electrons from another atom. And likewise, for carbon, has 4 valence electrons. It needs to wrap, share, transfer with another atom that has 4 valence electrons. For oxygen here, it has 6 valence electrons, so it needs 2 more valence electrons, so the octet is complete. And for chlorine, it has 7 valence electrons, so it needs 1 more valence electrons, so the octet is complete. So they receive additional electrons either by transferring or by sharing the electron from the other atoms. There are two types of chemical bonds, the ionic bonds and the covalent bonds. The ionic bonds are formed when a metal cation is attracted to a non-metal anion. In the previous chapter, you learned about ion. Ion carries either a positive or a negative charge. So for positive charge, we call it cation. For negative charge, we call it anion. When an ionic bonds are made, they form formula unit. For example, sodium ion and chloride ion. This sodium chloride is formed by the electron transfer between sodium and chloride, and they form sodium chloride formula unit. Covalent bonds, on the other hand, they are formed when two nonmetals share valence electron. Now, if you look at ionic bonds here, go back and look at ionic bond. They are formed when a metal cation attracted to a non-metal anion. For the covalent bonds, they are formed when two non-metal share valence electron, 2 or more non-metal. So when covalent bonds, they form molecules, and therefore molecule would be represented one of the representative particle. So the two representative particles here, we got formula unit and molecules. Formula units are formed by ionic bonds, and molecules are formed by covalent bonds. And it's an example of covalent bonds or molecule at water with method one oxygen and two hydrogen share an electron, forming chemical bond between oxygen and hydrogen. So let's talk about ionic bond for now. An ionic bond is formed by the attraction between a positive charged cation and a negative charged ion. If you just think about it, just like a two magnet with two opposite poles, the north and south, like positive and negative charge in the sodium ion and chloride ion. So ionic bonds are formed by the attraction between the positive charge cation and negative charge anion, like an example of sodium chloride. So how are cations are formed? Cations are formed when an atom loses advanced electrons to become positive charged. Most the metal group, they achieve a noble gas electron configuration by losing the advanced electron, and therefore they isoelectronic with a noble gas. This term we learned in the previous chapter. Isoelectronic means they have the same number of total electrons. Now magnesium, which belong to group 2, can lose 2 valence electrons to become magnesium 2 plus, and you also learned it in previous chapter. The magnesium ion now only has 10 electrons because it lose 2. It's a total of 12. It lose 2 electrons. Now it only has 10 electrons, and therefore it is isoelectronic with neon. If you write electron configuration, magnesium will be 1s2, 2s2, 2p6, 3s2. It loses 2 electrons, it becomes 1s2, 2s2, 2p6. It's the same electronic configuration as neon. We talk about formation of cation. How about formation of anions? Anions are formed when a non-metal atom gains electron and becomes negatively charged. Remember, we say if you gain something negative, you become more negative. But you lose negative, you become more positive. So for anion, it gain more electron, it become more negative or become negatively charged. So non-metal achieve a noble gas electron configuration by gain electron and become isoelectronic with a noble gas. Why a noble gas? Because noble gas have the octet complete. So chlorine is an example. It belongs to group 7A or 17. It gains 1 electron, become chloride ion. Now chloride ion has 18 electrons because chlorine had total of 17. It gained one electron, therefore it has 18, and it is isoelectronic with argon. If you write electron configuration of chlorine at 1s2, 2s2, 2p6, 3s2, 3p5, when it gains electron, that electron go into 3p5 and therefore become 3p6. This one, a chloride ion electron configuration of chloride ion, is the same as electron configuration of argon. Now you can use the electron dot formula to predict the formation of anion or cation. Here is a symbol for cation. You can see electron dot formula of sodium, magnesium, and aluminum. Because of 1 electron, sodium have 1 valence electron, it can lose that 1 valence electron and become some sodium plus. Magnesium can lose 2 valence electrons, become magnesium 2 plus, and aluminum can lose a 3 valence electron and become aluminum 3 plus. When they lose 1, 2, or 3 valence electron, they have the same total of number electron as in neon. So at the electronic configuration is the same electron configuration in neons. Likewise for anion, the non-metals and period 3 that we use here, chlorine, sulfur, and phosphorus, can gain 1, 2, or 3 electrons respectively to form anions. And now each non-metal is isoelectronic with the fallen noble gas argon. It is the same explanation as I show you over here. Chlorine can gain 1 electron, sulfur can gain 2 electrons, phosphorus can gain 3. Why they gain? Because they have 7, 6, and 5, and therefore the octet is complete. And when the octet is complete, it has the same electronic configuration as in argon. So let's talk about the atomic radius of these when the ionic bonds is formed. When an ionic bond is formed, the atoms lose electron or gain electron. When an atom lose electron, become a cation. This cation, the radius is smaller than the radius of its stone atom. For example, you compare sodium plus ion and sodium atom. The sodium plus ion had a radius 0.095 nanometer, where its starting atom, sodium atom, is had a radius at 0.186, so smaller. Now, in contrast, for chlorine atom, when it gain electron, the become chloride ion. Chloride have the atomic radius is bigger than chlorine atom. The atomic radius of chloride is 0.181 nanometer, but for chloride atom, it's only 0.099 nanometer. So when an atom gain electron, the atomic radius getting bigger. When an atom lose electron, the atomic radius getting smaller. We talk about ionic bonds. Now let's talk about covalent bonds. So covalent bonds are formed when two non-metal share electron. And the share electron in the covalent bond, they belong to both atoms. Let's look at hydrogen chloride as an example. When it's formed, the hydrogen atom share one valence electron with chlorine. Remember, hydrogen belongs to group 1, so it has one valence electron. Chlorine has 7, belong to group 7, so it has 7 valence electrons. The electron from hydrogen can be shared with chlorine, and now both of them happy because hydrogen has 2. It's octet complete. Remember, hydrogen is an exception that it doesn't have it's octet at 2 and not 8. For chlorine, now you can see that around is an 8 valence electron, and therefore it octet it complete. And it forms a bond between hydrogen and chlorine, and this bond we call it covalent bonds when electrons are shared. Just like we talk about the atomic radius of the ionic bond, and the bond length when electrons are shared between two atoms is different than what you think. You would think that when hydrogen and chlorine atom, when they form a bond, the new molecules, the bond length will be the sum of the atomic radius of hydrogen and chlorine, which is not true. The bond length of hydrogen chlorine molecule is smaller than the sum of atomic radius of hydrogen and chlorine. Remember, the electrons are shared, so they tend to be squeezed to each other or close to each other, and therefore the radius between the radius from the total radius from one atom to the other atom is smaller. Bond energy. Energy is released when two atoms form a covalent bonds. When an example here is hydrogen gas and chlorine gas. When they come together to form hydrogen chloride, they produce heat. That's the same amount of heat needed to break hydrogen chloride molecule into hydrogen gas and chlorine gas. So the energy is required to break a covalent bonds. It refers to the bond energy. And that amount of energy required to break a covalent bond is the same as the amount of energy released when the bonds is formed. As an example I show you here. We will talk about the topic in the next video.